Millimeter waves are very attractive because there's much wider bandwidths available. And with those wider bandwidths, you can transmit much higher data rate compared to what we use right now. But the big challenge with millimeter wave is that the signal doesn't travel very far.
Millimeter waves have a lot of spectrum available, but they also come with compromises in propagation and absorption by materials. So it makes it hard to create a long-range link on millimeter wave.
You're not going to get coverage everywhere because it does get blocked by solid objects. It won't penetrate concrete walls. The human body, anything that has water as the primary ingredient would shadow or block the signal.
What we've developed here at MixComm is we have power amplifier technology that gives you 10 times higher power at 2 to 3 times higher efficiency. So what that means is with the 10 times higher power, you can transmit for around 3 times more distance. It'll essentially make millimeter wave communication links more reliable. They'll drop out less. You can also use that higher power to get higher data rate as well.
The previous generation, going back to about 40 years ago, when we started with 1G, it was all about voice telephony.
I think that we've seen 2 wireless revolutions so far, and we're on the cusp of the 3rd one now. The first wireless revolution, I think, took place in the 1990s, and I think of that as the mobile communication revolution. It enabled us to have essentially mobile phones, handheld devices, with which we could be immediately connected to anybody across the world while on the move.
And then from 3G and 4G, there was this monumental increase in the capacity, which really allowed the technology to be cost-effective and more widespread.
The second wireless revolution, I call it the mobile data revolution, and that I think spanned from the 2000s to roughly around 2020. So we're at the tail end of that revolution right now. Data rates became so high in our handheld devices that we could essentially get on the internet from our handheld devices while being on the move. What I think we're going to start to see now, and this is roughly contemporaneous with the rollout of 5G and future Gs, 6Gs and so forth, so starting in around 2020 and beyond, is the 3rd wireless revolution, which I think of as the mobile reality revolution. And what I mean by that is that now wireless will enable us to interact with the real world in new ways. And this includes things like virtual reality, augmented reality, imaging that's now actually vision quality.
Now moving on to 5G, the technology, we find ourselves at a place where we are congested in terms of spectrum, and we have to now start looking for frequencies such as millimeter wave frequencies, which have been hard to use in the past.
5G will have 2 frequency ranges. There's what's called sub-6 5G, which will go into possibly any of the bands that are currently occupied by cellular. And then there's the millimeter wave 5G, which will be in what's called the 28 gigahertz bands and the 39 gigahertz band.
There's the 60 gigahertz unlicensed band, which is essentially meant to be the next generation of Wi-Fi. It'll enable you to transmit very high resolution video, 4K video without any form of compression wirelessly. This is very important to the gaming industry, to have set-top boxes that can communicate with TVs wirelessly so that you can eliminate all the annoying HDMI cables that you have flying around your house. Right now, virtual reality headsets all have a wire or a tether that essentially connects you to the computational device, and that really hinders the truly virtual or virtually real experience that you're trying to have with it. There's also millimeter wave is used in automotive radar. So this is in radars that are in cars today that essentially are used for automatic cruise control, side impact warning, parking assistance. And so our technology is directly applicable there to improve the performance of the radar. There's satellite communications, consumer satellite communication applications that are coming up that are also at millimeter waves as well. So there's several millimeter wave applications that our technology also applies to outside of 5G, which is our primary focus.
So the technology that MixComm's bringing to bear, it allows for consumer-grade communications to be offered at a price that is affordable for the mass market. So it will take millimeter wave out of the very narrow applications it's historically been and make it a global consumer application.
There's a strong interest in our technology to, again, improve all dimensions of the millimeter wave radio that would be used, which are data rate, size, cost, and range. We can use wireless to interrogate what materials are actually made of, and so on and so forth. They will enable new applications that are imbued with artificial intelligence that have the ability to process this massive amount of data and actually give us back information that's valuable. And so that's what really excites me, and it particularly excites me that our technology has the chance to, in some small way, enable that.